Hello, welcome to the session 2 of operational amplifier. Okay, so I thought that online teaching it would be a lot easier, but it's not. This is actually my fourth attempt to record this. Okay, so without much further ado, so welcome. Let's start with the session 2 of the operational amplifier. So I had a question last time with my first lecture. So what's the difference between non-inverting and inverting in terms of circuitry? Okay, so let's take a look at the non-inverting. So as you can see here that the RF is connected from output to input, output to negative input, then you have the RI, and then you have the input here connected at the positive. Okay, so whereas for the inverting, so again we have RF from output to input, then we have the RI connected to the negative input, but take note of the V in here, it is connected at the negative. So as you can see that the RF and RI, they're in the same place, but it is the Vin that defines whether the circuit is inverting or non-inverting. So if the Vin is connected to the negative input, so that means it is inverting. Whereas if the Vin is connected to the positive input, okay, so that is non-inverting. So that's how you differentiate the inverting from non-inverting. Okay, so you take a look at the Vin. So take note that RF is connected to the output to input. So pin 6 to pin 2, then R is connected to pin 2 to the ground. Okay, so it is the Vin. Again, it is the Vin which defines whether the op-amp is inverting or non-inverting. So if it is a non-inverting amplifier, so we have Vout is equal to 1 plus RF over Ri Vin. Okay, so let's have an example. Okay, so given the circuit below, determine the voltage gain and Vout. So we have RF of 1 mega ohm, Ri of 100K, and a Vin voltage of 5 volts DC. So op-amp or operational amplifier, okay, can have an input of either DC or AC. Okay, so since this is a non-inverting, Vout is 1 plus RF over Ri times Vin. So the 1 plus RF over Ri is actually a voltage gain. Okay, so when say voltage gain, so that is the ratio between output and input. So let's take the next slide for the computation or solution. Okay, so we have AV is Vout over Vin. So we have for voltage gain, we have 1 plus RF over Ri. So we have 1 meg over 1K is 10 plus 1. So we have voltage gain of 11. So Vout is equal to AV times Vin, 11 times 0.5. So we have 0.5 volts Vin here, DC is equal to 5.5 volts. So if we can use VOM to measure the output here. So I should be able to measure 5.5 volts. Okay. Next. So given the circuit below, determine the voltage gain and Vout. So we have feedback resistor of 1 meg, input resistor of 100K, and Vin of 0.25 volts peak. Take note, so in this example, so we have an AC input alternating circuit. So we have alternating current alternating current. Okay, so we have Vin of 0.25 volts peak. Okay, so we have AC input or alternating current. Okay, so again, this is non-inverting amplifier because the input is connected to the positive. So Vout is equal to 1 plus RF over Ri times Vin. So let's take a look at the computation. Okay. So to compute for voltage gain, so we have again 1 plus RF over RI. So you have RF is 1 meg over 100K. So 1 meg over 1K ohms is 10 plus 1. So we have voltage gain of 11. And then for output voltage, so we have AV times V in. So 11 times 0.25 volts peak is equal to 2.75 volts peak. So how we're going to draw the input versus the output. So this is the input. So you have, take note, you have 0.25 volts peak, so you only have this amplitude. Okay, so we can view this using oscilloscope, and we may use function generator to generate this oscilloscope. So we may use function generator here as a voltage input. Then we may use oscilloscope to measure this sine wave. So we have V in of 0.25 volts peak. So after at the output, so after the signal goes through the non-inverting, so you should expect to have a output of 2.75 volts peak. So take note that the output should be in phase with the input, meaning if the input is in positive cycle, so V out should also be in positive cycle. So they should be in the same phase. Okay, but the output is bigger, has a bigger amplitude. So you have 2.75 volts. Any question? Question? Okay, none. So if you have any question, please PM me. PM is the key. May PM me through MS Teams or through Messenger. So whatever applies, whatever is applicable to you. Okay, so now we proceed to inverting. Okay, so this time the V in is connected to the negative input, but the same connections. The RF is connected to from pin 6 to pin 2, and then RI is connected to the pin 2. Okay, so it is the V in that actually defines it as inverting. So since the V in here is connected to the negative input, so since the V in here is connected to the negative input, so that makes it inverting with the formula of negative RF over RI times V in. Okay, let's have an example. Okay. So we have here, okay, so again we have RF of 5K, RI of 1K, and we have a DC input, direct current of 1.2 volts here. Okay, so what would be the voltage gain for this circuit? So since it is inverting, so we're going to use this formula. V out is negative RF over RI times V in. So the negative RF over RI is actually a voltage gain. Voltage gain for an inverting amplifier. Okay. Next, so we have, this would be the solution. So for the voltage gain, V out over V in is equal to negative RF over RI. So negative 5K over 1K. So we have negative 5. So V out is AV times V in. So negative 5 times 1.2. So you shall have an output of negative 6 volts. Okay. So if you're going to use a VOM, so you should be able to measure negative 6 volts here at the output. Next, so we have next example. Okay, given the circuit below, determine voltage gain AV and V out. So we have RF 15K, we have RI of 5K. This time we have input voltage of 0.5. Take note that the polarity of battery is now reverse. So you have the negative here now connected to the input, inverting input, whereas the positive is connected to the ground. So therefore, in effect, so you have a negative 0.5 volts input. Okay, so since again it is inverting, so you have formula for V out is negative RF over RI times V in, wherein negative RF over RI is actually the AV or voltage gain. So we have, okay, so this is the solution now. So AV is V out over V in is equal to negative RF over RI. So 15K over 5K. So we actually have an voltage gain of negative 3. Okay. So what would be your output? So AV times V, negative 3, but we have an input of negative 0.5. Why negative? Because the negative here is connected to the negative input. So it is the negative polarity of the supply of that is being connected to the negative. So therefore it is negative 0.5. So you have voltage gain negative 3 times negative 0.5. So you're going to have a positive 1.5 volts output. So we're going to use VOM here. Should be able to measure 1.5 volts. Next, so we have number 5. Okay, given the circuit below, determine voltage gain, AV and V out. So this time we have a AC input, alternating current. So with 0.2 volts peak. Okay, so we have RF of 100K, RI of 10K. So V out is negative RF over RI times V in. Okay, so let's take a look at the solution. So we have AV is V out over VI, negative RF over RI. So we have negative 100K over 10K. So we have negative 10. Okay, negative 10. So V out is AV times V in. Negative 10 times 0.2 volts peak. So you have negative 2 volts peak. So how are we going to draw that? If we're going to draw that, so we have a 0.2 volts here, 0.2 volts peak, 0.2 volts peak input, whereas V out is 2 volts peak. Take note that they have a 180 degrees out of phase. So the negativity here means that the negativity here has nothing to do with the amplitude, but rather with the phasing. So negative here that the output is 180 degrees out of phase with respect to input. So if the input is positive, the output would be negative. So that's what it means. But nevertheless, it's the output still amplifies with respect to amplitude, but it has a negative phasing with respect to input. And then last, we have voltage follower. For voltage follower, we have V out is equal to V in. Take note, you have no resistors here. You have no RF, no RI, but you have the input connected at the positive. So what's the use of voltage follower if it has no resistors at all? So it has uses for voltage follower. It has its application. So it can be used as a buffer. Can be used to restore waveforms, okay, regenerate waveforms, okay. So kung napapagod na kayo, you need you need to refresh, so you need a voltage follower, okay, to refresh your energy. So that's what voltage followers do. Or it can be used to isolate from one circuit to another. So you have the voltage followers such that the output does not affect the input. So you have something in the middle. So that's what the voltage followers do. So I isolate the one circuit to another, or it can be used as a impedance matching. Okay. Got it right? Okay. So now let's proceed with opamp in cascade. So this is just a simple circuit. So we're going to do it step by step. Okay. So this is our example number 6. So now we have opamp in cascade, wherein the output of opamp number 1 becomes the input of input number 2. So example here, we have 2 opamps. So determine the voltage gains AV1, AV2, and VO1 and VO2. Then sketch the output vis-a-vis input. Okay. So how are we going to do that? So first, before you solve for anything, you have to determine whether the circuit is inverting or non-inverting. First things first, okay? So for op-amp number 1, so you determine if this is inverting or non-inverting, okay? So I'll give you 10 seconds to guess. So if op-amp number 1 is inverting or non-inverting. Okay, so I hope you got it right. So op-amp number 1 is inverting. Okay, why? Why it is inverting? Because the voltage input is connected at the negative. Okay, so therefore it is inverting. Okay, how about op-amp number 2? Okay, so how are we going? So the output of op-amp number 1 becomes the input of op-amp number 2. So therefore op-amp number 2 is inverting or non-inverting. I'll give you 10 seconds again. 6, 7, 8, 9, 10. Okay, so if your answer is inverting, you're wrong. You're wrong because the output of op-amp number 1 is being connected to the positive of op-amp number 2. So that makes it op-amp number 2 to be non-inverting. So for op-amp number 1 again, we have inverting here. Op-amp number 2, we have non-inverting. So you have to be very careful with that, okay? So we have here op-amp number 1. So again, it is inverting. So the formula for voltage gain is simply equal to negative RF over RI. So take note, we have an input of negative 0.25 volts peak. So for AV is RF is 1 meg, RI is 400K. So we have a voltage gain of negative 2.5 for op-amp number 1. So the output of op-amp number 1 therefore is AV1 times Vin is equal to negative 2.5 times 0.25 volts peak. Okay, so we have a output of 0.625 volts peak. So you have negative, negative, so positive 0.625 volts peak. But then take note that V out 1 is equal to V into Y because the output of op-amp number 1, meaning the pin 6 of op-amp number 1 is being connected to the pin 3 or a positive input of op-amp number 2. So therefore the input per op-amp number 2 is equal to 0.625 VP. Okay? But then before that, so we compute for AV2. So since AV2 is non-inverting, so we're going to use the formula 1 plus RF over RI for AV2. So ratio of 1 meg over 500K, so that makes it 2 plus 1. So we have a voltage gain of 3. Okay? Then multiply that to determine V out 2, AV2 times V out 1 is equal to 3 times 0.625 VP. Take note that 0.625 VP is actually the V out 1. Is equal to 1.875 VP. So if we're going to sketch that, okay, so if we're going to use oscilloscope, we should be able to see this. We have V in of 0.25 volts peak. So it says here negative, so that's why we started at the negative cycle. Okay, so negative cycle, so 0.25 volts peak. So VO1 would be positive, so that's why it becomes positive here. Okay, and VO2 is also positive, so 1.875 volts peak. If you have any question in mind, please feel free to PM me. Okay, so that's it for now. But oops, I have a surprise. So I have a activity for you, quiz. Okay. Given the circuit below, determine the voltage gains AV1, AV2, and AV3, and V out 1, V out 2, and V out 3. Sketch the output with respect to input. Okay. So Okay, so don't be confused. Okay, be out one. So again, so first things first, determine what circuits, op amp number 1, op amp number 2, and op amp number 3. After that, you proceed with computation using the applicable formula, and then sketch the outputs with respect to input. So you have to sketch the input first and then the outputs. Okay? So please send me your answer through MS Teams, preferably using MS Teams. But if it is not accessible to you, please PM me. Okay. Please write your answer in a piece of paper, then you take a picture. I'd like to see your handwriting. Don't forget to write your name in your paper. And that's it. That's all for now. I'm sweating. So hot. So I hope you're okay. You're in good condition. Uh, Keep safe, everyone, and eat healthy foods. Eat a lot of fruits and veggies. Then sleep early. Don't stress out. Don't stress your parents. Okay. So I hope we can get through this. So that's all for now. Bye.